Welcome to the Professional Data Engineer Crash Exam course. Today's focus is the cloud storage, a highly reliable and fully managed service. Let's get started. GCS is a highly reliable, fully managed object storage engine. It supports media delivery, backup and DR, data lakes, and is a viable Hadoop HDFS replacement for cloud-native big data transition. The global namespace requires unique bucket names across the entire GCP platform. Buckets are basic containers holding your data, and objects are individual files accessible through unique URLs. Flat namespace is the default, simulating folders via object name prefixes. Hierarchical namespace, or HNS, introduces true folder resources, enabling atomic folder renames and mitigating hotspotting, which is ideal for Big Lake and AIML model checkpointing. GCS offers 4 storage tiers: Standard for frequent access, Nearline for infrequent access, Coldline for very infrequent access, and Archive for archiving/backup/drive. Durability is extremely high at over 9 nines with millisecond latency. AutoClass automates storage economics. It promotes frequently accessed objects to the standard tier and demotes infrequently accessed objects to colder tiers, eliminating manual copy and delete processes for cost savings. The billing engine calculates total cost based on storage costs, operations usage, network usage, and penalties, like retrieval and early deletion fees. Labels and tags are used for tracking and enforcing security policies. GCS offers 3 geographic footprints: multi-region for highest availability spread, dual region for an optimal balance of high availability and low latency access, and region for high local performance and single region workloads. Turbo replication accelerates redundancy, ensuring 100% of newly written objects are replicated across regions with a 15-minute recovery point objective, RPO. This minimizes data loss and ensures service continuity during outages. Defense in depth for data integrity includes retention policy, object holds, soft delete, and object versioning. Encryption supports Google-managed keys, customer-managed encryption keys, and customer-supplied encryption keys. Programmable object lifecycle execution uses IF conditions, such as age and storage class, to trigger then actions, like changing the storage class or deleting objects, automating data transitions to colder storage classes. The transit decision matrix guides ingestion based on data origin and volume. For data originating from S3, Azure Blob, or existing GCS, storage transfer service is often used. For large on-premises data, a transfer appliance may be needed. GCS is integrated into the event-driven ecosystem. Real-time spiky ingestion is handled by Cloud Run and Cloud Functions. Data processing integrations include Dataproc, Dataflow, and BigQuery for seamless downstream analytics. Access control can be uniform, relying strictly on bucket-level IAM or fine-grained, combining bucket-level IAM with object-level ACLs. Public access prevention, PAP, strictly enforces 0 objects are exposed to the public. Ephemeral access and external interoperability are secured using signed URLs, signed policy documents for complex uploads, and HMAC keys for migrating workloads from AWS S3 to GCS without rewriting authentication logic. Operations are centralized with storage intelligence, including Gemini Cloud Assist and inventory reports. Data integrity is verified by the Data Integrity Scanner using CRC32C hashing for error detection and verification checks after download.